My name is Gustavo Goni. I've been here at AOML for 22 years last week. So, and I have always been very glad to work in this lab and with a group of people in the division. And probably I imagine that that is what you are going to see reflected in all the talks. And we have a vision that is also a goal. That is to carry out observations, analysis, compare with ocean models that help us to understand the state of the ocean, of various parameters in the oceans like ocean currents and temperature, salinity, and how the changes in the ocean actually affect ecosystems, climate, extreme weather events, fisheries, with a final goal of protecting lives and property. I don't know if the time is working. Let's see, maybe not, maybe I have to change myself. I don't think it's working. Try go. So in order to accomplish our goals, we have objectives. And I'm going to show you here 7 of our objectives that we have in our division. We start by proposing hypotheses and by carrying out research to address these hypotheses. Central to our activities is to carry out field work and data management of the observations that we are obtaining. We conduct with those observations data analysis. We have a group that does numerical modeling, and we do data assessments. This is very important because it's not very common to within the oceanographic community to do data assessments and ocean simulation experiments. Also important to us in order to accomplish our goals is to carry out technological developments. Some of the equipment that we use, you can buy straight from Seabird or from other companies. Others are developed here in the division, and you will have the opportunity to see that during the tour to the engineering facilities. We perform scientific communications. This is in the form of peer review manuscripts, attending workshops, symposiums, and doing outreach activities, our web pages. And we have discussed, you have heard before the presentations how we perform transitions and operations. And I'm going to show you some of those to show you who our clients are, who is actually using our data and our products. And we do this with funding. We receive base funding and we write proposals, and I'm going to show you how the different sources of funding have changed over time. This is how we are. We are 50 members in the division, 20 of whom are federal employees, and 30 cooperative institutes, CIMAS employees, or contractors. Important to our division is that 60% of our members are underrepresented minorities in STEM fields. This is for NOAA is very important because it has been recognized that having underrepresented minorities improve the hiring, improves the retention, and improve the performance of not just of the employees, but the whole group. We have 20 scientists, 20 science support. We have postdocs, usually stay here for 2 to 3 years. And part of our work is to mentor our postdocs. And we usually have a very good number of high school students and undergraduate interns during the summer months. I will go through a few slides that are dedicated to our major research areas. The first one is about the ocean state and variability. We make observations, so we contribute, or we do it ourselves, to create assessment of the state and variability of the ocean. The parameters that are more important to us are boundary currents, surface and subsurface currents. We are heavily invested in the division and are central to the monitoring of meridional overturning circulation and heat transport in the Atlantic Ocean. We're located in Miami. Tropical oceanography is also central to the research that we do. You will see presentations, lightning presentation on each of these topics. And we also study regional sea level changes. There will be a presentation on that before, following mine. We are extremely interested in how the ocean impacts extreme weather events and at different time scales. The impact of the ocean for forecasts of tropical Atlantics, that is in the weekly time scales, and going to seasonal and beyond. We work with other NOAA line offices to create outlooks for tornadoes and droughts, and they will be included in the lightning talks that you will see. We have a very small but very strong numerical model group that whose activities is focused on Atlantic hurricanes and monitoring meridional heat transport and meridional overturning circulation. Here is where the work that we carry out is about data impact using numerical models to assess the impact of individual platforms and to eventually design through OSIS optimal observing systems. We work with our colleagues in fisheries to study how environmental changes in the ocean within climate models may affect stock assessments in the future. We also work with them in fisheries in the Gulf of Mexico by using satellite and in situ observations to identify regions that are appropriate for different species. We recently started working with biogeochemical studies, and we support the Ocean Chemistry Division on ocean acidification studies. And I will show you some of the work that we do on sargassum. This is our funding through the years in our division. Our current funding is approximately $12 million, 8.5 coming from proposals. I included there the supplemental funding that we receive, and as it was stated before, come from gliders. And the base funding has remained flat during the years. The last peak that you see in 2019 is actually because of supplemental monies. But it shows you the general increase in funding that we are receiving in the division, and you will see how that actually translates in the enhanced research that we are doing. What we like to call the bread and butter of our division is to carry ocean observational activities. In many of these activities, we go from end to end, or we are key players in critical components of the ocean observing system. We start with the design and implementation, then it comes the maintenance of the different components of the ocean observing system. We obtain the data that we transmit in real time or do the delay time QC, and the analysis and model assessments allow us to identify changes in the state of the ocean or go back to the design to redesign the ocean observing system. Rick Lampkin in next presentation will show you some of the main observations in which we lead here at AOML. These are global or regional observations. This is a list, and the picture that shows you there is one of the deployment of an inverted echosounder. That is a system that is placed in the bottom of the ocean, sends a signal to the surface, comes back, you measure the travel time, and it gives you the dynamic height in the ocean. We have several of these instruments in the North Atlantic and South Atlantic with our partners, and it's helping us to monitor the meridional heat transport or overturning circulation. To give you an idea of the type of effort that our employees place in carrying out these observations, our employees have spent more than 500 days at sea this year. But this is not just in NOAA ships or just by ourselves, but they are done together in collaboration and partnership with more than 60 international or domestic institutions. I had there in the previous version a number that was actually, we had more than 50 cruises this year. That includes to maintain the Pirata Array, Western Boundary Time Series in the South Atlantic, gliders and XBTs. What you see there is the deployment of an inverted echo sounder, the instrument that you saw before, that we're doing at 27 North in of 27 North in the North Atlantic, and the ship is from the University of Miami. That is what we call medium-sized operation, and well, yeah, and these are some of the institutions. When I mentioned 60 institutions to carry that collaborate with us in observations, but we also collaborate with them in doing data analysis, data processes, numerical modeling, and this is, it goes from government labs to shipping companies to international laboratories globally. This is the list that I just named to you. And what we do that is not only to contribute, sharing knowledge, but also to leverage resources. And I have listed here 3 of the main areas in which we leverage resources. For ship time, we have our NOAA projects that we do in collaboration with countries. I listed there Brazil, Argentina, South Africa, and while we provide some equipment, they provide the logistics and the ship time. For our glider operations that have been growing during the last year, we collaborate with many countries in the Caribbean Sea, and they provide the glider ports, and they provide also ship time and personnel to be in the ships to deploy and recover the gliders. And for our XBT transects and deployment of Argo floats and surface drifters, we have extremely good connection with cargo ship companies that provide us free of charge on a volunteer basis the opportunity to deploy these instruments. The work that we do in our division is also done in collaboration with the other, some of the work in collaboration with the other 2 divisions. I listed here a few of the work that we do together with HRD. You previously heard about how we are assessing together through observations, analysis, and numerical models the impact that the ocean has on hurricane intensification. This year, for the first time, we are officially part, the observations of our division, officially part of the Hurricane Field Program within NOAA. And with Ocean Chemistry Division, we have a long history of collaborating in repeat hydrography, thermosalinograph observations in support of PCO2 assessments, and to assessing ocean conditions during red tide events, and doing climate ecosystem assessments. What I listed there, that is an intersection between the 3 divisions, is what we would like to do, we're planning to do in the near future, is to assess the impact of hurricanes on ocean conditions, but also on oxygen and PCO2 and ecosystems. But central to the work that we do is our collaboration and what our role is within the different NOAA line offices. With marine fisheries services, especially Southeast fisheries across the street, we work very closely to create fisheries or ecosystem indicators. And with NESDIS, we collaborate Are you waving at me or telling me that I have 5 minutes? Okay. With NESDIS, we co-lead the CoastWatch node here at AOML with NOS and OAR. We studied sea level attributions. And with the Weather Service, which is EMC and the Hurricane Center, we are collaborating very closely on our ocean observations deployments for hurricane studies, specifically intensification. We are part of several, more than 50 scientific panels. And this is important because it helps us be part to gear science research in the future with a NOAA objective. And we have participated this year in the Oceanography 19 Frontiers of Marine Science. We have 17, there are 17 papers in which divisional, PhD divisional staff were co-authors. 3 of them we led. Rick Lampkin was editor of one chapter in the BAM's State of the Climate, and the division contributed with 8 different manuscripts. And this is a histograms of how many manuscripts the division has produced through the years. And it's very important also to notice that Dennis Volkov here, Greg Foltz, myself, Rick Lampkin, and Libby Jones, we also act as editors of different journals. On the science that we do, that you will see the lightning talks, is very important. The ocean is our backyard. There is an issue, there is a problem, and with sea level rise, and we are studying attributions to sea level rise. The picture that you see there is when we are maintaining the pressure gauge of the Bahamas. Both temperature and the Florida current transport are key to understand why the sea level are changing. We started 4 years ago with implementation of what we call a glider picket fence for hurricane studies. This year we just finished, last week we finished a very successful season in which we deploy AOML gliders of in the Caribbean Sea and of Florida. And together with our partners and other members that are listed there below, we have provided in the region more than 100 temperature and salinity observations in areas that were not very much surveyed before. And these data are used to initialize the HICOM component, the ocean component of hurricane intensification models. George Halliwell will show you later how actually representing the ocean correctly can help you to reduce the error in hurricane forecast. Work that we do here for meridional heat transport also has allowed us to investigate how changes in meridional heat transport can affect regional and global rainfall due to monsoon in ecosystems. The work that Sanki Lee will present will show you how ENSO actually modulates the impact, the amount of plankton biomass that it is found in the Gulf of Mexico. And all our research is actually broadcasted live, our seminars broadcasted live through YouTube, and they are recorded and you can find it there. And we also carry transitions. One of the very important transitions is that we make observations and people use our data, the data that we transmit in real time. This is the data that is used for the forecast model. And this is a list of per year how much data we transmit in real time. Other transitions are related to the impact of oceans on heat waves, of the oceans on tornado activities, and also on monitoring ocean circulation for oil spill study. We provide the real-time surface current fields to NOS, and this is used in one application for oil spill studies. We study sargassum, and we provide, I'm done, 2 slides, and we provide weekly maps of sargassum inundation. This is very important in the region because of the implication of sargassum in tourism or also in health. Together with CoastWatch, we started this year working on displaying where real-time ocean data is obtained, and that is helping the hurricane field program to also direct their observations. You will take a tour of our engineering facilities. Looking into the future, we were talking about our new generation. This year, we started funding graduate students at Erasmus. These are the first graduate students that the division is funding, and they will be with us 5 years and studying topics that are directly related to NOAA. Our focus in the future is to continue having a lead presence in ocean observations, in particular now with autonomous technology, and also incorporate new areas in our portfolio. And they are all listed there, and you have it in your presentation. So these are the talks that you will be now seeing, and thank you very much. Sorry it took a few minutes longer.